As we already know, an operating system is the main software that helps our computer work. It helps connect us to the internet, allows us to run different programs, and it helps manage our computer hardware so that everything works well together. Here's what we're going to cover in this video on the main functions of an operating system. We're going to talk about how an operating system controls resource management, process and memory management, file and directory management, as well as hardware abstraction and networking. In terms of resource management, our operating system helps manage our physical resources, our CPU, our memory, and some of the other devices on our motherboard. Resource management mainly helps with sharing a computer's memory, its power, its various devices, and again, its various resources. Those are namely the GPU for graphics, CPU for any type of processing, and RAM for helping manage different active and open programs. Resource management is important because overall, our computer needs to be able to manage resources and allocate them in the right way in order to run properly. There's only so much resources we have on a physical computer, and the operating system helps us manage those. For example, an operating system itself will take up resources. An application that's open is going to take up resources. Same thing with having 20 different Google Chrome tabs open. That's going to take resources coming from the CPU and from the memory or from the RAM. So keep in mind, this is what resource management does. It helps us not only improve system performance, but manage it and make sure that our resources are there and provisioned exactly where needed. If you'd like to see resource management in effect, you can open Task Manager now if you're on a Windows laptop or desktop computer and look through Task Manager at what applications are running, what are taking up certain parts of the CPU and memory, what some of the background applications for the operating system are, and overall you can start to get a picture of resource management. And if you do end up opening up Task Manager, you'll see something like this. We can see all of our available and running processes. We can see that the CPU is being allocated to certain areas like all these Google Chrome tabs. We've got a ton of memory being used, especially for Chrome, and we can see the different applications that are open and what resources they're demanding. That's what resource management is it's provisioning out those resources so that we can actually use them. Same thing when we're going to save different files. We have a set amount of storage space and we have to make sure that we fall within that storage space and not exceed that capacity. That's what resource management helps us do. Here's a more visual representation of resource management. Here you can see the operating system controlling CPU, memory, or RAM, as well as storage. Additionally, the operating system will manage other parts, for example, like the graphics card if you have a dedicated graphics card and you're doing something like gaming. Resource management has two main categories. Process management focuses on CPU and other system resources. Meanwhile, memory management focuses on RAM and active memory resources. These are both a type of resource management, both process and memory management. And process management, again, mainly CPU focused. Memory management is more RAM or memory focused. So both has their own job, but just remember process, CPU, memory, RAM. And those are the active resource management for both areas of CPU and RAM. In addition to resource management, our operating system also helps manage our files and provides us directories to do that. File management is essentially how we use our operating systems in order to store, organize, create, and overall handle files on a device. Directory management, on the other hand, is how our folders are organized to keep files easy to find and to keep them tidy. Essentially, our files store data such as Word documents, images, videos, programs, really any file that you've ever downloaded and can think of, while our directories actually contain the folders that we use to organize our files and store things. So think about it from this aspect. Let's say that we have a file. We'll call it Subway Orders here, subwayorders.docx. So it's a Word document file. You can visualize it like a paper with information on it and a label. So here we have our Subway orders, and this is our file. From here, we also have a folder. This is called lunch orders. This is a folder with a label or a name that holds our file or a piece of paper. From here, this folder can then store our file. We can do this with any type of file. So in this example, this is a folder that holds a file. In this case, we're just talking about my lunch order and it's from Subway, right? But we also have our directory structure. And in this case, you can think of our directory structure almost like an area where we store our different folders, essentially something like a filing cabinet. So I could take this folder and put it in a filing cabinet, and that would almost be like our directory structure. In this case, I'm going to actually show you what that directory structure would look like from the perspective of us being on our desktop, which is part of our file directory. and showing you our lunch orders folder and our Subway orders file in that folder. Now, you're probably already familiar with file management and directory management, and maybe my example is a little bit extreme for this concept, but just know for the specific knowledge that you need to understand, file management is essentially how we store our files and create our files. Our directory management is how we actually organize those files. So here you can see this file management example. On my desktop, I created a folder called lunch orders, and then in the lunch orders folder, I have my Subway orders document. Next up is hardware abstraction. Hardware abstraction, or HAL, essentially allows all the software that we use on our computer to communicate with our computer hardware without needing to know any information about the hardware. So think of it kind of like an intermediary between our hardware and our software. That's what this part of our operating system does. So while file directory management and file management help us sort and organize and create all of our different files, hardware abstraction, on the other hand, is the part of our operating system that's doing that bridge between our hardware and our software. It essentially makes software easier to develop and run on a wide variety of different operating systems and be compatible with a wide variety of different laptops and computers, and it can also help our system stay stable and allow us to run different applications. Here's an example of this. So we have applications going to the kernel of our operating system. Then we have this hardware abstraction layer, and that's what's actually communicating with the CPU on our motherboard, the memory, our timer, our ports, and different devices and peripherals. So that's where things go. They go all the way from our applications that we're running down to our kernel in our operating system, down to where here is the hardware abstraction, or HAL, lies. Next up is networking roles, and this explains how our devices are able to actually work together and share information on a network, whether that's on the internet or whether that's on a more local network. So there's two main types of networking roles, and we've talked about these previously. I'll cover these again, but you should already remember them from our previous section, because we've talked about these quite a bit. So a client server, remember, that's when a server is acting as the provider for information or files. And then we have our peer-to-peer setup. Remember, that's when our computers are acting as peers, and they're essentially giving files or information to each other directly. So essentially at the top, we have a server for client server, and it's feeding multiple different clients information, downloads, data, things like that. And then again, peer-to-peer, it's that setup where computers and devices are communicating directly with each other. We've talked about that quite a bit, so we won't handle that too much here. And overall, those are some of the functions of our operating system. So you can start to see the different areas our operating system actually starts to work, what different things that it supports, and also we talked a little bit about how it integrates with the rest of the operating system as a whole, particularly with our hardware abstraction and how it communicates to things like the kernel and the more broad operating system in general.